All right, let's go ahead and get started. Again, my name is Mike DeLaCluse. I'm with the Lessman Instrument Company. I'd like to thank all of you for taking time out of your busy schedules to join us for our 15th customer webinar, which is titled, Which Wireless is Best for Me? It's going to be presented by Dan Weise, also from Lesman. Dan's been around industrial wireless since the first day we got involved, a little over 8 years ago. He's been instrumental in designing and implementing many of the applications for our customers. So not only has he had to put all the pieces together, but he's also had to make it work. Today's webinar is going to cover which wireless is best for me, where you'll get some insight into the evolving standards, current and evolving field instruments being brought to the market. As an instrumentation vendor, we're in a very interesting position. Most of your instrumentation vendors will only have a single vendor or standard to discuss with you. In our case, we have Honeywell developing products for the ISA 100 standard, while we have Phoenix Contact and Siemens developing products for wireless HART. A couple of our other vendors, Banner, Phoenix Contact, and Honeywell, also have proprietary wireless networks, so we have some experience with those as well. This position gives us the ability to talk about the strengths and weaknesses of all of the different technologies without really being partial to any. So we really look to put in the best wireless technology for your application, not the wireless technology that we have to offer, because we have all of them. Again, the phone lines will be muted. If you have any questions, there is a chat box down at the bottom, and you can use the chat box, or you can hit *6 and you will be unmuted. At the end, we'll unmute everyone, so if you want to save up your questions, feel free to ask them at the end. With that introduction, I'm going to turn it over to Dan.
Thank you, Mike. Good morning, everyone. Before we jump into this, let's just review real quickly where industrial wireless is at this point in time. We've had several decades out there where industrial customers have used licensed walkie-talkies and SCADA. And then about a decade ago, license-free wireless started to come into the market that used this ISM band and didn't require focus on is license-free stuff. It's the industry-appropriate stuff that's packaged for us. And you can read on the slide there the kinds of things that the industrial radios bring to the picture, that we're not looking at the consumer kind of stuff that's just kind of shoehorned into an application. A recent article came out on controlglobal.com, which is one of our industry's trade journals, and it had a very interesting survey up there. The article was entitled "All Quiet on the Wireless Front," and the interesting one to me is that the little segment there that said only 11 people are undecided on wireless at this point, that a lot of people have already jumped onto the bandwagon and at least gotten their feet wet in wireless. And here's the bar graph that shows what they've implemented. Now, you got to take into account this is not a scientific survey. This is something that was done by a trade journal, and whoever responds to the trade journal survey is whatever number they have at that. But the big bar on the left over there, that's Ethernet implementations, and that could be as simple as Wi-Fi for people that are taking their laptops out around the plant. The next one here is the proprietary networks, and the third one, interestingly enough, is wireless HART. And then there's also some Bluetooth on there, but it's interesting to see how people have jumped into it up to this point in time. So if we sort of summarize this, a decade now has given us literally dozens, if not hundreds, of different vendors out there with wireless offerings. There are some standards out there. There are electrical standards like Ethernet, Bluetooth, and cellular. These are all defined by things outside of our particular industry. And then within our industry, we have ISA 100 and HART wireless, which are here to try and define standards within the process data acquisition and process transmitter type markets. But there's also a whole bunch of proprietary protocols out there, which leaves a user standing there saying, which wireless is best for me? There's a whole bunch of decision paths that seem to be out there, and there's confusion as to which one is the best. And in my opinion, the answer is there is no single best wireless out there. There's no one model that fits all, and that doesn't happen in wireless just like it doesn't happen in baseball caps. You can see on the graphic there, for something as simple as a baseball cap, there's 4 different styles of caps, there's 4 different headbands, and it's just a baseball cap. But look at all the permutations you've got in that. When you hop over to wireless, we have the most comprehensive and inclusive system out there is the ISA 100 one that actually has 3 radios in it. It has a field device radio, a Wi-Fi radio, and a backhaul radio. But even this system can't carry your analyzer that's talking Modbus. So at this point, it's not all-inclusive. Will it be down the road? Probably. I can't imagine how they're going to ignore it. But at this point in time, it's not all-inclusive. So in my opinion, I think wireless is likely to remain a mix-and-match proposition that's going to fit what you're trying to do. So when you look at this thing, you really need a decision tree to try and sort your way through this, to try and find out what is the best solution for you. Well, it all depends upon what you need to do in your work culture. So you sit down and you try and figure out what your goals are, you see what you have to work with, and then you match that up against what's available out there. This is a comparison matrix for the stuff that we've got. The stuff going across, all these stuff up here, these labels up here, they all define, for the columns going down, all the different wireless networks and all of the different technologies that are used therein. And then down, going across on the rows, is all the stuff that special to that given network. And the blue highlights are those things that are clearly superior for any of these. And the easiest one to see up here is that if you just want to do monitoring, almost any of the stuff out there will do monitoring. Once you get into control, there are far fewer options available to you. And of course, as you look through that complex matrix, you say, my gosh, how do I know where to go? Well, let's start and take this step by step. And we'll see that the first thing you look at is determining what do you want to accomplish. What's the purpose? Monitoring or control. Again, if it's monitoring, it's fairly easy. If it's control, there's a whole bunch of other things that you've got to look at. But you also look at what you've got to work with, meaning what kind of data you're dealing with, how much data, how many points you're dealing with, area and site factors, concerns, and what's also critical is what constitutes usable data once you get it into the radio. You've got to be able to work with it once it's there. By the way, for those that are trying to scribble notes here, and I'm flying through the slides, you don't really have to, because we've come up, or we're actually working on, it should be done shortly, with a wireless network planning guide which incorporates all of this stuff. So if you send us an email at the end and say, I want your wireless network planning guide, we'll send one out to you, and you can rest easy and not have to take a bunch of notes through the webinar here. So in looking at the purpose here, again, if it's monitoring, it's easy. If it's control, there's a number of things you got to look at. Number one, do you have to be bidirectional? Some people are more than willing to take in a process variable and then do the decision making in the controller and feed the control signal back as a wired signal. Others want to go back wireless. So you got to make sure that the system you get is capable of doing that. It's really important to look at the update rate, because in control, obviously, some control situations have to be updated more frequently than others. And there are trade-offs here. The higher the baud rate, the less power per bit. That's a fact of physics. A lot of these battery-powered devices use a sleep mode in order to conserve the power, and using up power for transmission diminishes the battery life. So there are trade-offs here when you're using it with control. A really critical function is how is fail-safe addressed. You've always got the situation where a field sensor can fail. Now you got a situation, like you do with wire for that matter, where the link can fail. And just like there are fail-safe ways of wiring binary devices and relays out there so that you go into a known fail-safe condition, you have to address this when you go through wireless also. The nature of the data that you're dealing with determines which wireless technology and the network you're going to use fits. And so we got to look at the kind of data you're looking at, and it falls into different categories here. The first one is process data. It can be I/O, classic I/O, which is 4 to 20 analogs and discretes. You might have actual transmitters out in the field which are generating this data, although typically when it's a wireless transmitter, it doesn't actually have a 4 to 20. You're actually sending a digital number over. And then there's also the serial data stuff. This is Modbus, Ethernet IP, DF1 from Allen Bradley, or just plain old ASCII characters. Different radios handle this kind of data differently, so that has to be taken into account right up front. If you're doing video surveillance, that's a huge amount of data. You got a byte for every pixel on the screen. There are multiple screen updates per second. This is a huge volume of data compared to the process data. It's definitely an Ethernet Wi-Fi radio type application. Some people do this for wire consolidation. That's where they got a bunch of analogs and discretes coming into the field. They want to get that wireless back to a central control point or back to a central data acquisition point. At the far end, that then breaks into a radio that receives it, and there's an industrial protocol that puts it on a single wire, puts it into the PCS, the PLC, whatever that's dealing with the data. There's diagnostic data out there. Wireless HART has just opened up the whole field to getting the diagnostic data out of the field devices out there. What you got to take into account here is that the diagnostic data is valuable only if you put it into an asset manager type application that's designed to handle that diagnostic data. So the data is out here in the field devices. It comes in wireless to a gateway. The gateway then hands it off to the asset manager. One of the questions you got to look at is, I got information that I want from the field. Are the sensors out there already, or do I need new sensors? There's a whole bunch of people out there that are providing field-based transmitters that you hook up to the process. They generate the data. And if they're wireless to start with, then you're getting digital numbers directly. You can also retrofit HART devices with the wireless HART adapter to bring that data back for your legacy devices that are already out there and wired, but you can't get the multiple variables out or the diagnostic information. On the other hand, there are people that just want to come back to wired information. And the graphic down here shows a terminal block where there are a bunch of people that just want to deal with 4 to 20s and discretes and put them into a device, and that's totally doable also. One of the basic questions is, how much data are we going to deal with? In the graphic on the bottom down here, this is the most simple system out there. It's one analog variable or one discrete into that transmitter. It gets shot over to a receiver on the other end, and it's remade into whatever it was at the beginning. It's called wired in, wired out. If I put an analog in, I get an analog out. If I put a discrete in, I get a discrete out. And on the other hand, we have entire plant-wide systems that can take hundreds, if not thousands, of points. When you're looking at this, you always got to have a reality check where you sit down and you decide, okay, this is a wish list. We wish we could do everything out there. Now we got to divide up or take out those that are the got-to-have ones so that we can make this realistic and actually justify it and get the money for it and go put it in. While you're looking at this, though, you also got to look at, if we want to add those other points on the wish list, what's the potential for future growth? How can we scale it up? The system on the right here, there is no scaling it up other than to duplicate it with just another set of radios like that. The system on the right is just add another transmitter, add another point, configure it, and you're into the system. So there's a huge scale in between, or a huge spectrum in between of how you scale devices or how you scale networks up or adding devices. There's a whole bunch of area factors, and they're all in the end going to affect the radio's RF power, which combined with the antenna determines whether or not the signal gets through. The graphic on the bottom just shows you a typical high gain on the antenna, with the white part being that sort of wireless RF energy envelope that spreads out and goes to the far ends like that, and the big circle around the antenna. That combined with the amount of energy you start with determines whether or not the signal is going to get through to the receiver so that you can get it into your system. We all know that RF energy decays over time. What we got to watch out for is what I call cookie monsters. Cookie monsters just eat up radio energy. Tree leaves and pine needles just suck it up. Wet earth is probably the worst out there. Nothing gets through wet earth. Even a body of water can distort it if you don't have enough elevation above it. You can't have a real low antenna over water and get it across to the other side. It just doesn't make it. Masonry can be shot through depending on how many walls you've got there, but it's still something that attenuates the signal. So we got to watch out for these cookie monster things that eat up the energy. On the other hand, you've got things that are what we call radio heaven. The inside of a steel metal building is just absolutely wonderful for getting signals through, because the signal goes out, it bounces off the steel, and it goes everywhere. It's literally like an echo chamber. The other thing that doesn't seem to be too much of a problem are the canyons of steel, all that superstructure and stuff that you find in a lot of plants, processing plants. that tend to reflect the RF energy and get it to where you need it to go. So when we look at the area factors, it's how big an area you've got and the topography, the distance between the points and the elevation between the points, so that you can make sure that the antenna you're using actually intersects with, the transmitter antenna intersects with the receiver antenna. And you got to look at all the obstructions, as you can see in the graphic there. There's also non-stationary or mobile operation type applications. We've actually done stuff where we put radios on the back of those little Jeep type things and they scurry around the construction site. There's the stuff that moves, like the, I'm drawing a blank here, the kill, the rotating kill up there. And of course, wireless is ideal for this because it's battery powered, so you don't have to run wires to it, and it can rotate around with the kill. And then we got the big coal scooper there too. It always helps when you're looking at this stuff to start out with a map. It doesn't have to be a big map like this, because this particular application has to be 3.5 miles from the top to the bottom on there. But even with it, whether you're working with a room or a series of, or an area within the plant, get a map and start and put the dots down on it so that you can, it helps you count the dots and establish where you are and where you got to get to. Some of the site factors to look at that are specific, again, to the kinds of radio that will be selected are hazardous area use, whether or not you've got power, and what you got to deal with for indoor and outdoor enclosure requirements. There are concerns that people have with security. A lot of these are addressed with encryption and passwords. For streaming cellular, there's VPNs that are considered secure in the wired world, and they're considered just as secure in the wireless world. There are proprietary protocols that are just difficult to deal with in the first place. Frequency hopping as a technology has its own minimal level of security. And then there's things that are being developed like low-profile antennas just for anti-vandalism, so the antenna doesn't stick up and encourage the kids in the neighborhood to come by and throw rocks at it or tear it down. There's one thing that we want to bring up front, and that's that if you're going to be taking some of this data in on the plant network, you probably want to deal with the IT department up front and bring them in so that you can make them feel like they're participants in this. Most of them haven't said no. They just want to make sure that whatever you're going to do is not going to compromise their business side of the IT stuff. And there's also a question as to how important compliance to a standard is in making this decision. Some people, it's very important. Other people say, it doesn't matter to me as long as the stuff works. That's all I'm interested in. And another factor that some people have ignored until it's brought to their attention is, what do you consider to be a usable form of data once you get it from the field? Because the data eventually comes into a gateway or a master radio, and then you got to get it out of there and get it to the destination. And here with the bullet, you can see the list of the kinds of things that you would get the data to. Each of those things is very particular about how it's going to accept its data. And what's usable data for one guy is not necessarily usable data for another guy. Some people want wired in, wired out. In other words, if I start with an analog in the field, I want to wire an analog into my PLC, and that's it. Other people can handle the industrial protocols, the ASCIIs, Modbuses, Ethernet IPs, OPC hard, all that kind of stuff. They have people around that can do that, and that's fine with them. Some people just need alarm-type information in the form of a text or an email message. Comes along, text messages are fine. Email tends to be a little more permanent because it's usually in an email file somewhere. And then there are also the Ethernet protocols, HTTP, FTP, XML. This is the kind of stuff that you typically use in a web browser. You might not be aware of that, but that's the protocols that are used behind the scene to bring the data up and show it to you. But in any case, you got to be able to handle whatever it is when it comes out of that gateway. There's no magic there. It's an application that has to handle it in the end. You got to make sure that the application matches with the kind of radio that you're going to put in there. And we actually had this where somebody ordered the radios out of the catalog, got them, and he actually he expected to get out wired I/O that would fit onto these Phoenix contact connectors right here. What he ended up with what he ordered and purchased was a radio that had an Ethernet port on it. Well, there's no way to directly connect an Ethernet port to these wires over here and get any usable data out of it. He needed a different kind of radio in order to make it work. So this is an example of what you want to avoid by making sure that you take into account how the data is going to be usable when it comes out of the gateway or the master radio. We want everybody to be a happy camper. So what are the solution considerations after you've gone through and figured out what you've got to work with? Well, there are 4 different major technologies out there: Bluetooth, frequency hopping, direct sequencing, and cellular. And then there's also all the stuff we've just been through, which are the factors that you have to take into that you're dealing with. Bluetooth is much more than the little headset that you stick over your ear when you're dealing with a cell phone in the car. Typically, it's wired in, wired out stuff, but there are 3 different classes of Bluetooth power out there, and the industrial uses the highest powered class, which will actually give you distances up to 1,000 feet, which is something over 300 meters. It tends to be very wide bandwidth and fast throughput. It really has a lot of application out there for inside the plant stuff. As you can see from the picture on there, it's not it's not a NEMA 4 type thing. It's got to be mounted in a panel. It's all exposed wiring terminals, but it works very well and very fast for fast throughput. Frequency hopping is really dynamite for industrial data. The frequency spectrum down here on the blue graph in the lower right shows you the high amplitude peaks where the data is packed into one pulse or one packet of data and shot out, and it's got a very high amplitude to it. And if you were looking at this on a spectrum analyzer, these peaks would actually move to different frequencies each time they go up. That's why they call it frequency hopping. But we relate this to the bullet, which is a very targeted, high-powered type situation where the data punches through and gets through. It is absolutely ideal for I/O type data because process variables are bytes, discretes are bits. It's a relatively small amount of information that can be bundled up in a packet and then shot out at a high energy packet. You compare that to direct sequencing. Down here with direct sequencing, we have nowhere near the amplitude, but we have a whole bunch more data that's contained in the area under the curve there. And this is more like the shotgun approach, where in a shotgun you have a whole bunch of pellets, each of which is a bit of information, and you can shoot it out, but a shotgun doesn't have the range of a rifle, and it doesn't have the, if you want to say, the combined power or the concentrated power of a rifle, so it doesn't tend to punch through. Direct sequencing is used by all the Ethernet radios, and it's ideal for transferring large amounts of information. So anything that Wi-Fi, which is your laptop computers, that type of thing, that's all Wi-Fi. It's web-based stuff. It's file transfer stuff. And it transfers a large amount of information, but it also, because it's a large amount of information at a lower amplitude, it tends to be more, it can be broken up more easily. And when it gets broken up, then the radios have to renegotiate and resend the stuff, so it's susceptible to background noise and interference. And if you don't need that kind of data, you're much better off to go back and use the frequency hopping stuff, because it just, the radios that use frequency hopping just punch through better than the direct sequencing ones do. There's a whole field out there now for cellular. There's 3 forms of cellular. We only deal with the first 2 up here, the GMS, which is the text, and the GPRS, which is the data streaming. GMS is really great because it sends a text message on alarm, and it'll send it typically either as a text or as an email. The streaming down here can actually hook up to process data. It assumes you've got an industrial protocol and stream the data. The cellular modem down here is where you actually make something into you tether it, like you can take a cell phone and tether it to a laptop where the device acts as a modem. And we don't really get involved in that because that's really a carrier-only service. But people look at it and say, what's the cellular got going for it? And it's the map. I mean, there's in a built-up area like we're in, there are not a lot of areas that are not well served by cellular. So if you've got remote locations, meaning remote over many miles away, cellular is a way to get data back to where you're dealing with it. The real difference between cellular and all the other radios, though, is that with the other radios, since you own them, you don't pay for the actual operation of it. You do with cellular. With cellular, you pay a subscription, and then you pay per message or per byte as the data streams through. And, of course, there are packages like there are for cell phones. But the point is you're still paying on a monthly basis to get the service that you need. When we look at control, we got to look at update rates, because control typically needs to be faster than update or monitoring. And each of the networks has its own characteristics. If you update more quicker, you're going to diminish your battery life. And here's a warning for people that deal with the serial data. When you connect to a serial radio, like a Modbus radio, the connection rate is not necessarily the radio throughput rate. You can connect at 38.4 kilobytes, but the over-the-air comm could be at 9.6 or 19.2. You got to look at what actual transfer rate you need to make the operation work, and then select the radio that's going to get the data through at the rate that you need. And it disappoints people, but there is a rule in wireless, and that rule is conversion always slows things down. When you do a serial to Ethernet conversion, the Ethernet part is fast, but it doesn't make the throughput any faster, because you still got to convert from serial to Ethernet. And you might have to convert it back again on the other end. When you do anything to wireless in the digital world, it slows it down. Now, walkie-talkies are analog, right? So they don't, that's real time. But conversion to wireless does take some time, so there's always some inherent latency in there. Repeaters or meshing also slows things down. So you can put that stuff in there, but there is a time delay in that. And you just got to be aware of it. And the area challenges, where we're looking at things like topography, trees, elevation, low spots, or where you're running mobile applications, we got to look at the radio output power. Some radios are as low as 30 milliwatts, others are as high powered as 1 watt. And you got to apply the ones where they're going to work. The topography challenges are particularly low spots, and sometimes there's no way of getting around that other than to use a tower that gets your antenna up above the grade so that it can actually get the signal out to where you need it. There's also using repeaters so that you can get around earth mounds or over obstructions. And now there's also meshing networks that can use other radios in the network automatically as repeaters to get around to the gateway where you need the information in the end. Antennas are really where a lot of the design factors come in, because they're the ones that take the radio energy, focus it, and get it to where it's needed. There's two general types. There's omnidirectional or directional antennas. And the directional ones, they focus the energy in a particular pattern. None of the antennas actually create more energy than the radio puts out. All they do is they squash it into particular patterns so that they can focus the energy, and so that the receiver antenna intersects with the now focused energy, which generally takes a longer path than the unfocused energy. There are some rules, and that's that, for instance, if you're inside a metal building and you got to get the signal out, you got to put the antenna on the outside of the building, because the radio signals don't, as good as metal buildings are for keeping echoed signals inside the building, they're terrible for getting data outside the building. So you got to mount the antenna on the outside of the building. And you got to put the antennas where they're going to clear the obstruction and the foliage. Sometimes that means getting them up on the rooftop. We recommend lightning surge protection for all the stuff outdoors. You're much better off burning up the $100 surge protector than you are losing the radio or the receiver device that it's hooked up to. People ask, is a site survey necessary? Well, it is sometimes. If you got really long shots, yeah, we probably want to do a survey for that. If there are lots of obstructions, yeah, we probably want to make sure that it's going to work. But if you have open line of sight over a given distance, we can probably just look at the chart and say, yeah, it'll work. No survey necessary. For the hazardous area stuff, there's lots of Class 1 Div 2 options out there. There's lots of Class 1 Div 1 field transmitters, and there's even one of the repeater devices over here with the dual antennas on it that is a Class 1 Div 1 device. So yes, we can handle hazardous areas. Power for the radios. This is a biggie because line-powered radios tend to have higher output than battery-powered radios. So if you've got line power, by all means use it. But then again, people a lot of times, they're going to wireless because they don't have power where it is. They don't want to run the wires for the power out there. If you're going to run wires for the power, why not run another cable for the signal? So, you got to look at this in terms of trading off what the batteries can do versus what you're trying to do out there. People have also asked about solar power, and you got to be aware that the Wisconsin and Illinois area tends to not have the kind of weather that the Southwest does down in Arizona, New Mexico, and therefore the solar tends to need very large batteries to cover the time periods when you don't have solar to make the energy, and that tends to be expensive. It can be done, but it tends to be expensive. What the good news in all this is that with the sleep mode that these devices do, batteries do tend to last more than a couple years. So it's not like you're out there throwing batteries in the thing every 3 months or every 4 months. There's always the things about enclosures. You can see here we've got radios that have exposed terminals on them. They're designed to go into a panel. Then we got the kind where the terminals are on the inside of the box and the cover goes on there with a gasket, so it's NEMA 4. And we always recommend surge protection when you put stuff outdoors. Again, the usable form of data when we approach this is the answer to the usable form of data is if you need wired out, we've got stuff with wiring terminals on it that'll give you the signal as wired out. If you need stuff that's Ethernet, we've got that also, or serial protocols. And if you need text or email, that's the cellular stuff, and you pick a radio that's appropriate for that. So how many baseball cap options are there? Well, you can calculate it there. How many wireless options are there? Well, you can take a look at the chart and see. What does Lessman bring to the party? Well, we're actually here to try and help you figure this out. You know, to go through this exercise of figuring out what you're trying to do, what you've got to work with, and then matching that with an appropriate radio. So we got all this pre-sale stuff. We've also got startup and commissioning services. We can build panels for you if you need panels, and the maintenance. And our Lessman University is the periodic webinars or classroom stuff that we put on to train people how to put it up and how to maintain it, or like this, how to pick it. What we offer out there is 7 real tiers of radios. The first one is the high-density I/O stuff. This is where you're working with classic analogs and discretes. You put it in at one end, you take it out at the other end, either as I/O, serial, or Ethernet data. Then there's the low-density option. This doesn't have as many I/O that you can put into it, but it does the same thing. You can take it out as I/O, serial, or Ethernet. Then there's the serial-only stuff, because a lot of things like gas analyzers, they only talk Modbus, or you got so much information that you can't take it out as a single process variable. So these kind of serial radios, they start as Modbus, Ethernet, IP, ASCII, and that's what you get out on the other end. Then there's the cellular stuff where you have I/O, like a flow switch that trips or a level switch that trips, and it sends a text message. Or the streaming data, which is the Modbus DF1 kind of stuff, where you have process data, comes into it in the form of Modbus, get it out on the other end into the HMI or the SCADA system. We've got wireless HART by both Phoenix Contact and Siemens. The big deal here is that you get not only the process variable, but you get access to the diagnostic data. It's all battery-powered field transmitter stuff. Honeywell has their battery-powered field transmitters in the XWire 5000. They also have it in the XWire 6000, which meets the ISA 100 standard. And then they've got the entire plant-wide network. This is the one that has the 3 radio networks. You've got your field instrument network. You've got a Wi-Fi network so that people can walk around with their laptops and around the plant and get internet connection that way, or intranet connection. And then it's got what they call a backhaul radio on it that transfers data between major collection points to get it onto the plant wired network. So in summary, after a decade of use here, we don't think industrial wireless is bleeding edge. It's now leading edge. A lot of the bugs and a lot of the problems have been worked out of it. It's approaching the mature stage at this point. And it works well as long as there's some planning and execution behind it. And again, my big thing is antenna selection and location are critical. When you do that, the radios tend to work and are reliable, and they get your data through for you. So that sort of summarizes our webinar this morning. If you'd like the Lessman wireless planning guide or network planning guide, please send us an email, and we can get that out to you. It'll probably be 2 weeks before it's finished, but at this point I'd like to open it up to questions out there and see if we can answer any questions for you. I think the lines are open, right?
Yeah, should be.
Yeah, what about Zigbee? How does that play into this?
Zigbee is inherently a meshing network, and it's also a low power network. None of the vendors that we have implemented Zigbee yet. My guess is that if there's a place for Zigbee, it's probably in the commercial building HVAC realm, where you got a lot of stuff that tends to be closely clustered. Probably works in the above the ceiling area type up there, where you've got HVAC components that you want to connect to one another. It just hasn't taken off in the industrial world. Who knows? There could be an entrepreneur out there that comes out tomorrow and says it's the best thing going. But when you compare that to what Bluetooth can do with the class of power that Bluetooth has right now, I'd have to say why, unless you really need the meshing characteristic that it brings to the party over what Bluetooth offers. So that's my opinion at this point.
What about BACnet IP, if you're going to get into HVAC?
Being located in the industrial market that we're in, BACnet has not been, you're probably the first person I've talked to in 8 years now that's wanted BACnet. They don't offer it routinely. I suspect that BACnet IP can be packaged on an Ethernet backbone, and if you want to shoot us an email on that, I can check into it. I can't imagine it's like Ethernet IP. It is a particular protocol that's packaged for Ethernet transport, so that once you put it on an Ethernet transport mechanism, it's up to the application on both ends to deal with. So if it's actually BACnet IP, I suspect that Ethernet radios will handle it just like they handle HTTP or Ethernet IP or Modbus TCP, all the other things that are packaged for Ethernet protocols.
Yeah, that's a problem for me because I'm trying to bring together HVAC, power management, and data collection out on the factory floor, and then combine it to like OPC into different data collection, and getting those 3 or 4 to play together. Also, how does this work when you have people that have Bluetooth in one area and you have 802.11b throughout the building, and you start deploying these on that 2.4 gigahertz? Are you getting into issues where you're messing with each other?
Yes. I mean, there's no way around it. I mean, it's a band of a certain width, and depending upon the energy that's working, where you see less of it is where it's outdoors, because it just tends to disseminate more. Where you really have to watch it is inside of the steel building thing, where you get the echo chambers. It can start treading on one another. There's, like anything else, it's a band. Actually, what I think is going to happen here is I think some of this is going to migrate to the 5.6 band also, just because that isn't as popular as 2.4 is at this point. Could you send me an email, by the way, on that? I'm danw@lessman.com. I'd like to look at that BACnet thing for you.
How good is the security on the from an encryption standpoint, so that somebody can't maliciously hack into a given Bluetooth device?
The Bluetooth thing has it's strictly an internal proprietary protocol. So if you have somebody that has enough desire to break into it and do that, as far as I can tell, it's probably hackable. I have a little white note somewhere on there. I can send that to you in terms of what it is, but I think it's dependent upon the fact that it's primarily a proprietary protocol. I think the ISA, in terms of security in general, I think the ISA 100 has, without a doubt, the highest level of security. Wireless HART is a tad below that. Some of the others are you got to be real careful with cellular phone and text messaging. It has a 6-digit password is all. You know, so to me that's sort of minimal security. But you know, again, these things are all at different levels, and you got to pick what you need out there. But if you want to send me an email, I'll find that wireless, that Bluetooth thing, and send it to you.
Okay.
Well, if anything, that probably sums it up for the questions there. If anybody has anything that occurs to you, my email is DAN, first name, W, initial for last name, at Lessman.com. Shoot me an email, and I'll be happy to discuss it with you. Or give me a call on the office phone here. So I guess that about sums it up. Thank you for attending today. We appreciate it.
All right, thank you, Dan.
Yep.